Have you ever looked up into the sky at night and started wondering the big questions? Why are we here? Are we alone in the universe? Is there life on other planets? I think exoplanet study holds an interesting way to answer some of these questions. I personally study exoplanets by designing telescope arrays that we will use to study the transits of exoplanets. So if you imagine our solar system, we have planets orbiting around the star, or around our sun, which is the star in our solar system. Other solar systems would also have such an orbiting pattern with planets going around their star. If you imagine my fist as the star of this other solar system and my finger as the planet, it could go around like this, or it could orbit like this, depending on the orientation and the geometry as you're looking from the Earth. If the planet is orbiting like this, we have no hope of seeing the transit. The transit occurs when the star moves in our line of sight in between the Earth, which is your point of view, and the star here. So when the planet moves in front of the star like this, we see a transit. The transit is when the intensity of the light of the star dips below its normal value. So when the planet is in front of the star here, the intensity of the light is lower than when the exoplanet is not in front of the star. Studying this transit, we can determine several different characteristics about this exoplanet. We can know its size, we can figure out the mass. From those two things, we can figure out the density. So if you have a certain density, we know that the planet could either be rocky, like the Earth is, and therefore could sustain Earth-like life, or it could be a gas giant like Jupiter, which we don't think has any life, but if you get really creative, you can start to imagine all kinds of bizarre kinds of life forms that could thrive in such an environment. Another interesting thing that we can measure by studying the transit of an exoplanet, which you might not be able to study by any other means, is the atmosphere of that exoplanet. So when the planet is in front of the star, light from the star could pass through the atmosphere of that exoplanet. And by studying the light that passes through that atmosphere, we can figure out what molecules are in that atmosphere. We could, if there's carbon, not carbon, maybe carbon dioxide, if there's methane, or if there's oxygen, these are all tracers that could point towards life. They are not necessarily proof of life, but they would certainly be a tantalizing clue for possible life-sustaining exoplanets. Thank you.